Hello, everyone. Let's give everybody a minute so they can join and we can start.
I didn't order my cappuccino.
Hello, everyone. Welcome to today's Fireside Chat, the future of data management, a thought leadership chat. My name is Diogo and I'll be your moderator. Before we begin, just a few logistical reminders. Today's discussion is being recorded and you are currently in a listen-only mode. You may submit questions throughout the session using the Q&A function in the lower right corner of your console. We will answer everyone's questions after the presentation. After today's webinar, you will receive an email with the recording. If you wish to contact us, please email us at team@singlestore.com. So let me introduce our speakers today. We have Dominic Ravita, he's the VP of Product Marketing here at SingleStore. Rick Negrin, he's the Field CTO at SingleStore. And Noel Johanna, he's the VP and Principal Analyst at Forrester. Welcome, Dominic, Rick, and Noel. Dominic, you now have the floor.
Thanks so much, Diogo, and thanks to all of our guests for joining us. I think we have a really exciting discussion today about the future of data management, and we're joined by our distinguished guest, Noel Johanna, who's a Principal Analyst and VP at Forrester Research, covering everything data from reading from your bio. It's big data, warehouses, data fabrics, data meshes, virtualization, Hadoop, translytical databases, NoSQL, ETL, and the list goes on and on. And so we're going to talk a little bit about that. Our other panelist is Rick Negrin, SingleStore Field CTO, and Rick has a background in product management across multiple databases, including SQL Server. And so I'm so happy for you both to join us for this discussion. Noel's going to get out his crystal ball in just a moment and polish it and sort of tell us what is the future of data management. We're certainly seeing quite a lot of change in the industry space, most definitely in the database space where SingleStore plays, but the broader data management ecosystem, when we think about streaming technologies, ETL, cloud integration, data catalogs, and the list goes on. So we're going to start the discussion today with asking Noel to share some of his recent research from the paper that he published back in February, The Future of Data Management, and then we're going to discuss that. And Rick's going to give some sort of examples that we've seen in the market from SingleStore's vantage point. We're going to give you a few chances to interact along the way with polling questions. And at the end, we'll open it up for Q&A. So you'll be able to, as Diogo mentioned, ask your questions in the chat panel there or on Twitter if you want to do it there, and we'll be responding with that. So without further ado, Noel, I'll give you the floor.
Yeah. First of all, thanks a lot for having me on this webinar to talk about the future of data management. I, as an analyst, get to speak to a lot of customers every day. And, a lot of customers tell us that, they struggle with data, right? I mean, data is definitely a big issue, especially as the volume is growing, especially as we get to the cloud, right? Or even the edge. How do we better manage the data? But also, how do we evolve our platforms to support these new generation of requirements, like real-time insights, like doing some of these advanced analytics, and so the discussion, obviously, I'm going to talk about it, is about where are we heading towards data management, right, in the coming years? What are things we have learned, but also what are things we can expect? Before I get obviously into the discussions about the big things we're going to see, the data explosion, I guess, is creating new business opportunities, and I guess close to 15 zettabytes of data. I don't know how many, like many zeros, I guess, right? But thing is that the data is coming in from all directions, right? It's about on-premises data. We also have all these new generation of sensor data coming in. We got data coming in from the cloud. We got data coming in from the smart devices, web applications, and SaaS applications as well, right? So the data explosion obviously creates these new opportunities. I think the importance of this is that, as you have more data, you can leverage this data. Based on our study, we find that only 25% of data is used for analytics today, right? Only 25%. So what happens if the 75%, right? Like why are people not using 75% of the data today? Well, because they don't have the systems, they don't have the approaches, they don't have the people, they don't have the skills, they don't have resources, all the above, right? And that's bad, because if you have a lot more data to analyze, you can get better predictions, right? So I think every organization today should leverage more data. In fact, my phone today has a terabyte of data available, right? Terabyte of availability of data, right? That's really encouraging, I guess, right? So zettabytes of data obviously isn't a lot. And in fact, this number is going to double in the coming years as well, right? So here's an interesting kind of a survey data which we did about a couple of years ago, which says, okay, what are the primary benefits your organizations have experienced as a result of using data management? Well, it's all about improving customer experiences. Very important, right? You got to improve customer experiences, improve data quality, consistency, customer insights, no surprises, right? So why are we doing data management in the first place? It's just not just for the sake of doing it. We're doing it for a reason. Is to improve customer experiences. This is obviously to improve your data quality as well. Data quality is a big thing as well, right? Because obviously organizations struggle with data quality, but there's also to reduce cost and operational efficiencies and all those other things as well, right? So FYI. Data management is the core for any successful analytical strategy, right? I mean, if you look at it, data, without data, you can't do AI. You can't do business intelligence. You can't do any of the blockchain, data lakes, database stuff, right? So data is important, but also data management, right? Data management means like data ingestion and transformation and governance and security and preparation. So all these are critical as well, right? So definitely data management is important because you have to convert the data into actions, right? So how do you do that, right? So data management really enables us to do. So let me get into some of the trends we see, or some of the future directions of where this is heading towards. Lack of standards, proprietary metadata, and siloed policies have made data management more complex. Today, organizations have a wide variety of data management tools. In fact, in your organizations, I'm sure you have 12 to 24 tools for data management. And why is that the case? For data ingestion is separate, data catalog is separate, transformation is separate, governance is security is separate. And the best part is that they don't talk to each other in terms of its metadata, right? Because you have different vendors, and each of the vendor have their own solutions and all products and all metadata, right? And this is a bigger complex issue. So in fact, this is an example here in this photograph you see where people try to get through and you can't get through it because there's no directions available, right? Each of these have their own path, right? So the biggest problem, I think, is rules are not really shared, models are not really shared. So what we are seeing happening in the coming years, in fact, it started to evolve, is that there's a need for this end-to-end integrated data management, which will drive the next generation of deployments to accelerate the use cases. Accelerate the use cases. No one wants to spend 6 months trying to build customer 360. They want it next week. Question is, how do you do that next week, right? And that's a very important point. Unless you don't have an integrated solution, it becomes challenging, right? And what we're talking about here is trying to do the ingestion, the transformation, the governance, the security, the preparation, the quality, the catalog, all together as a cohesive set of data management principles, right? This is very important. Right now, all of these are done in silos by different vendors, different products, and different solutions, right? So end-to-end data management has become important because you really want to deliver this value proposition quicker in terms of the use case deployment, in terms of the scenarios. Now, what are the technologies available to us to driving that is obviously data fabric is an architecture which helps you drive the results. It's still evolving, but certainly data fabric is one of the architectures to help you to drive end-to-end data management. Data mesh architectures are also evolving, which is more distributed, but yet federated governance exists with self-service capabilities, and data products definitely helps you as well, right? Another architecture which is helping organizations to drive better integrated solutions. Data virtualization is also accessing data across all these different silos in a more rapid manner, and data management for analytics, right? It's all about having all these things together as a cohesive set, as opposed to having it more individualized as well, right? So architectures are helping towards driving this end-to-end data management. As I mentioned, what is the biggest hurdle in organizations today is data management. And that's no surprising there, because all of these functions are so separated, and you spend a lot of time trying to integrate, orchestrate, govern, and do quality checks. And this is a big issue for organizations. And we believe the integrated data management, which includes metadata, policies, models, will become a bigger focus. We are already starting to on that journey. Over the next 5-10 years, you're going to see a lot more innovation around this to really bring them closer together. Oops, sorry, I guess I moved out too quick on that. My bad. Okay. Most organizations are lagging when it comes to supporting use cases, time to value. As I mentioned, what's happening is that their organizations are trying to do all of these analytics and microservices and fraud detection. And what happens is that some of these you want to do it quicker and faster. It's about time to value, right? But yet you're obviously under the principles that, well, it'll take some time. Just like big data, right? Big data obviously has been there for a while, but then people have spent a lot of time and effort trying to build these platforms, and no one wants to do that anymore. They want to be able to have these systems or applications or use cases done a lot quicker, like IoT analytics, microservices, fraud detection, customer 360, global applications, and risk, and what have you, right? So what we are seeing as a trend is that use case driven data management solutions will further evolve to accelerate deployments. Traditionally, we've had data management by itself, right, in a very generalized manner, right? So we had data management, which was doing generalized. Here's data management functions. You can do ingestion, transformation, governance, security. We never focused that data management to a use case like customer 360, like IoT. So what we see now evolving over the last few years has been this very use case driven data management. So for example is customer data platforms or customer data management solutions. Specifically, data management specifically tied towards customer data only, nothing else, customer data only. And why does it matter? Because the data management is aware about customer data. The moment you ingest the data, it knows it's customer data. The moment it transforms the data, it knows it's customer data. And that's a big thing. Why? Because it helps you accelerate that use case you're trying to do. If you're doing a general data management, you will take a lot of time and effort because the data management does not understand customer data, right? It does not understand customer data. But the use case driven data management solutions like CDP understands customer data by default, right? Something similar to IoT data management solutions as well. So we've seen IoT, where IoT data management solutions is all about IoT data, right? You're trying to get all these sensor data for IoT. The data management solutions, again, understand IoT data by default from built-in. It's built into the architecture itself and the platform. Like data sharing, collaboration, data marts, which is evolving as well. These data sharing platforms are many specifically mentioned for line of businesses who want to deploy these solutions a lot quicker, but also want to collaborate on these platforms by default as well, right? So we're going to see a lot of these examples of these more use case driven data management solutions coming in the making as well. And the key benefits is time to value, it's integrated, it's all inclusive, means all data management functions are inclusive, it's self-service. Very important point. Means that it's self-service driven from the user community who want to access the data, but also from an IT perspective, it's all about automation and simplification as well through machine learning and AI intelligence built into the platform, business focused, and obviously lower cost. And the third element I want to touch upon today is the whole notion of distributed data. Now, distributed data, as you know it, spans across on-premises, cloud, edge, is creating these new data management challenges. Today's data is spread across multiple clouds and multiple locations, including the edge. You have driverless cars, you have smart devices, you have all these things. Right? Now, these are creating obviously bigger data management challenges, right? Things like data security challenges. You have issues around governance. You have issues around performance and latency. I was on a call just an hour ago talking about performance on a distributed environment with a customer. And this is a known issue, right? As you have latency, as you have data distributed, you're going to have latencies across these clouds, across these environments, right? You got data quality issues, integration issues, duplication issues, administration issues as well, right? So this is definitely a big issue. So how do you deal with that, right? So we have now started to see this trend about this global data management solutions. Basically, what it means is that these are these new generation of data ops and global data management, which basically will drive the next generation of data strategy, which includes security, governance, administration. And basically what it means is that this data management is aware about the data locations. Very important point. So you can be accessing this data from Europe. It doesn't really matter where the data may be residing physically. It could be in US, in Austin, Texas, right? So it could be spread across, but yeah, the global data management, it provides you better control about data from a security perspective, from an administration perspective. We have started to see, obviously, technologies like data mesh and data virtualization and data fabric also enabling a global data management strategy as well. So this is going to evolve further as well. Why this matters? Because you don't want to duplicate data, right? Just unnecessarily duplicate data. You want to duplicate it for redundancy, but don't have to. You have to ensure consistency as well, right? Trustedness of data matters. Real-timeness of data matters, right? So global data management is definitely going to be a big focus area in the coming years. And the important thing here is to be able to provide a single pane of glass to manage, monitor, but also to access data, which may be sitting globally as well. So those are the three things which I wanted to talk about from a future perspective. Back to you guys.
Noel, thank you. It's lots to unpack in all of that. Something you said earlier around just the size of data, that's just really hard to get your head around it. Even on a smartphone, having as much as a terabyte on your phone. One of our engineers wrote an article last year titled "Your phone is already bottomless," meaning that even your phone is not limited now to just the storage on device. If you want to think about that device as an edge device, maybe the first globally popular consumer edge device, it now is pushing data, off to seemingly infinite low-cost cloud object storage, right? That really stuck with me too. I think
long ago that a terabyte server was considered a huge server and like, right? Put the terabyte on my phone. It's crazy.
Yeah,
that's true actually. I mean, and many years ago, 64 kilobytes was also big as well. But that's a different story, right? So, but yeah, but I want to say that cloud also is becoming a part of the edge as well. Cloud itself is becoming an edge. You're going to have multiple clouds at the edge as well, right? So think about that. Yeah.
Yeah, it's really shaping up to be fairly diverse as to what the edge is starting to sort of materialize. Another thing you mentioned there was like the use case driven part of data management, and you gave a few examples there. Do you have any recommendation, or are you seeing trends with what sort of use case driven data management companies should start with, or maybe companies of a certain size, you're finding that they start with, one data domain versus another? Is it always starting with customer domain, or is it sort of more vertical dependent there?
That's a good question. I would say definitely, I would say customer domains are the big ones, close to about 65%, almost 2/3 of all the deployments today we see for analytics have to do with customer data. No surprises there. but the remainder obviously is the other data sets as well, right? The IoT and engineering data, right? And social data and other things as well, right? And we can't forget those as well. But customer data obviously is important, and I think you start there. I mean, obviously, we recommend customers start with customer data, especially to improve customer intelligence, customer 360, to understand your customer better. No, every organization deals with customer, whether it's B2B to B2C or other types of environments. And you want to know exactly, like for example in Amazon, right? Amazon knows exactly what you like, dislike through your preferences and through your buying patterns and all those things, right? I think similarly with other retailers, I think they're trying to understand the customer, but also you want to go beyond just your initial buying experience, but also understand your social interactions, but also your additional maybe friends and family circles as well, right?
Right.
We call it multi-dimensional view of the customer as well, which is now starting to evolve. But I would say, yeah, that's the starting point of customer data. But then there's also IoT and fraud detection and risk analytics. But there's also industry-specific analytics as well going on. So.
Right, totally makes sense. I've got another question for you, but I want to launch this poll for the audience quickly while you answer this next question. But for the audience, tell us, what are you building today in terms of architectures, or what sort of data products are you building? Noel covered some interesting new kinds of architectures in his talk, covering data meshes, data fabrics, and some examples of other sorts of data, use case driven data management applications, customer data as platform, or an IoT analytics. So we're interested in like what you may be building out there. And Noel, I've got another question for you. You mentioned data virtualization. That's sort of an approach that's been around for quite a long time. What are you seeing that's the prime use case for data virtualization?
Well, the biggest issue is silos of data, right? We have now more silos than ever before. So silos, when we were on premises only, we had a lot of silos already emerging, CRP, ERP, CRM, and all these other applications. But as we went to the cloud, we realized we had more silos now, right? Because we got all these SaaS applications and new generation of applications. Data virtualization provides an abstraction layer to access this data across these silos as if it's all in a single place. It's pretty cool, right? So you don't really have to now query here, there, and there, make 10 different calls. You can make one call to a data virtualization and get whatever data you wanted in a consistent, trusted, real-time manner for applications, for insights, for analytics. And this is a big thing, especially as you go to the multi-cloud, hybrid cloud strategy, right? So data virtualization is definitely getting more traction over the last 4 or 5 years, primarily because of the cloud adoption, but also, it provides you a single location for getting you the data. It may not be physically located in a single location, but logically located, right? And that's what data virtualization does. It provides you metadata to getting the data from all these sources in a single location.
Totally makes sense. So I'm going to close the poll now, and let's take a look at the results. For the folks we had on today, interesting mix across the answers here. I guess most interesting, nobody currently on this call anyway is building an IoT analytics application. Surprised to see so many respondents though with real-time APIs. That's something that we're seeing more, I think, as something you didn't mention in your first section there was the monetization of some of this data. Sort of after you can get it organized, what can you monetize and turn into an external product for customers? And of course, part of the data mesh thinking is that even internally, you could be thinking about the data you expose to other organizational units as a data product. Now, when I was in the field practicing, we just call this common data services. But I think the data mesh takes that concept and sort of makes a more formal productization kind of thinking about that. So I'd like to invite Rick to sort of share his thoughts on a few of the themes that you mentioned by way of examples in the SingleStore user base. So with that, let me share your slides for you, Rick.
Thanks, Dominic. So I'm going to cover 3 areas, and it's the 3 areas you saw at the top of the poll there around real-time analytics, customer data platforms, and IoT. We'll start with the real-time analytics. So Dominic, the slide's not.
It's not. Let's try this again.
The slide. So real-time analytics is something that's kind of emerged, I think, in the recent, last 10, 15 years as a dominant thing. It's been gaining steam, especially in recent times. And if you think about it, like, wasn't that long ago that, that when I want to know what's in my bank account, maybe I'm dating myself, but I get a piece of paper in the mail like once every 30 days, and that was the information I got. And you fast forward today, and like if I don't see the credit card transaction I just did at the grocery store immediately show up on my app, I'm upset and thinking that something's wrong with my bank and thinking about switching banks. So people expect data to be up to date and at their fingertips all the time. And that cuts across not just consumer, but enterprises as well. A great example of this is True Digital. So True Digital is the digital arm of Thailand's leading telecommunication company, and they were trying to get ahead of COVID tracking back in 2020. And what they wanted was the ability to be able to track where there's large groups of people in an effort to prevent viral hotspots. So they wanted to be able to monitor real-time stats of geofenced areas, alert on population densities, basically anywhere in the country, and then determine what medical deliveries or testing would be needed for those areas. So basically as a pre-planning and to make sure they had the right gear and the right people and the right resources in the right place at the right time. And then to be able to take that real-time data and then combine it with historical data to enable a test and tracing at scale. Now they had something like 30 million phones. It generated about 500,000 events per second. So this is large-scale data and not trivial to do it real-time. They had built a prototype, but it was taking hours to do the pre-aggregations necessary to actually build the report. So they weren't able to deliver it in real time with the prototype they had built. And so they kind of broke down the requirements of what they wanted. They wanted to be able to do fast ingest, bring the data as quickly as possible, be able to do queries over this large data set, and not just the real-time data, but also the historical data, which is about 2 petabytes. They needed to be able to do geospatial queries over it, so they could, fence in to a particular area and understand what's going on in that area, and then to be able to do time series queries over both the real-time and the historical data. And so they leveraged SingleStore to be able to meet all those requirements. They're able to, so one of the key aspects is they're able to build the whole thing in less than a week. I think this speaks to the data mesh and the data fabric aspects, that they had all the pieces in place because they've been building all those elements, and then pulling it all together and putting it in SingleStore allowed them then to power the dashboards and provide enough power to all the people who are hitting it and trying to make use of the data. So they had, quite a few number of people hitting the system, so high concurrency, getting fast, low latency queries, and they did it all and built it all and got it up and running in 1 week, which is pretty amazing and a significant improvement and helped them combat COVID. So moving on to the next, let's talk about customer data platforms. So customer data platforms, if you step back a little bit, there's a broader trend here, which is around how do I make my organization data driven? And customer data platforms is sort of the leading use case for this pattern. But I need to take the data out from the behind the scenes where it's usually only been accessible by a few analysts who build reports for the C-level, right? And bring that data and make it available in a way that's insightful and useful for every employee in my organization, right? If I can empower all of them with data and insights, they can make better decisions on a day-to-day basis and drive the business forward. But to do that is non-trivial. You have to bring all these data silos, right? The silos that Noah was referring to, and bring that data together, because it's only when you join the various data sets together that you can get the insights that will help you make the right decisions. And then push that right to the edge, to the in front of the employees who are having to make those decisions, and have the data in a way that they can easily consume it to know what they want to do. So a good example of this is the Dell Customer 360 platform, where they had all these data silos. If you think about how big Dell is and how many, like they probably have every single enterprise as a customer and multiple touch points with thousands of different product SKUs and thousands of sales people who are all trying to work with different points within those organizations. And at the time, they had a pretty limited view of what the customer had been doing with the rest of Dell. And if they had that information, they could do a better job of bundling and cross-selling and upselling that customer. But without the information, they were kind of operating blind and not doing a good job delivering what the customer needed. So what they really want to do is bring all these data silos together into a single view that they could power a dashboard that would make it available to all their salespeople in real time. They wanted to make sure that all the data was up to date. So the real time was a key piece of streaming all the changes into the system and to be able to support high concurrency in terms of the thousands of people that were hitting this thing every day, trying to make sense of what the customers are doing with Dell and what advantage they could take from that in order to build the best possible package for their customer. And so by pushing all this data into SingleStore, they're able to build that real-time single view and really enable their sales team to have a much better insight into what the customers had already purchased and also what made sense for them in the future. And it made a big difference to Dell in increasing their sales and increasing their customer experience. That brings us to the third use case, which is around IoT analytics, right? And this is why the data in the world is growing so fast. Is it's not just coming out of a few operational systems anymore. It's coming out of every device that's out on the planet is generating data, and so many more and more of them are all being hooked up. So they're sending all that data back to some backend server or somewhere in the cloud or to an edge device or somewhere. And there's a huge opportunity if you can figure out how to take advantage of that information, particularly in real time, to do interesting things with that data. So Armis is a customer of SingleStore. They're a security company that basically takes all this data from devices and firewalls and IoT devices, all the devices that enterprises have in their networks, which is a lot of devices that are all constantly generating data, all different types of data, traffic data, asset user data, people going in and out of buildings. They bring it all back to a central location where they process it and analyze it, enrich it, aggregate it, and then make it available to those enterprises to understand what's happening in their within their enterprise and their physical and their digital areas in order to identify potential security breaks or leaks or any problems they might have with the system, so they can respond quickly. So they manage something like 100 billion events per day, and their largest customers have over 30 terabytes of data. So there's large data with fast moving data. And they wanted to be able to bring that together and make it available to their customers in real time. So really powering a customer experience where real time and large data were pretty critical, and be able to deliver sub-second queries to make it easy for people to drill down and get the information they needed, so they could stop any security attacks or ideally prevent the problems before they happen. Now they had tried building this on Postgres initially. They had a database per customer. They had hundreds of Postgres databases, and it wasn't scaling. And they tried moving it to another system, really a collection of various open source technologies to try to deal with the scale. But building that collection of technologies together got really complicated and expensive. That's what I was referring to. Like when you build these data meshes, the more technologies you bring together, the more complex it is to manage it, and the more expensive it is in terms of people and resources and hardware. And they were able to simplify the 3 open source technologies to just using SingleStore that really helped get them deliver on their real-time requirement needs, their concurrency needs, and building a much simpler system to make it easier for them to deliver this both on-prem and in the cloud. So just a great example of how one company is bringing all this information from all these IoT devices together and delivering a fantastic customer experience using this data mesh technology.
Terrific. Thank you, Rick. You mentioned something there around the more technologies that you use to solve these kinds of customer data platform, real-time analytics, IoT analytics problems, the more complex and costly it can get. But we as technologists feel like we need to bring the right tool for the right job for each of these things, which sort of leads us to our next point. But before I do that, I'd like to ask the audience just another poll here that sort of relates to this, which is maybe for these use cases we've talked about so far, or other use cases, how many database technologies are you using to support the application you're building? And what we're talking about here is just a single application. So you might definitely you are starting with some sort of primary database as an application database. But typically you might be using another database or type for analytics, or another one for your search index, maybe another one for product catalog information, et cetera, or even caching. So submit your responses there. We'll take a view of that poll in just a moment. And Rick, I wanted to ask you a question about something you mentioned there around, IoT analytics, and also the scenario for Armis and the scenario for True Digital. There's some commonalities there, in that in the True Digital case, they're using information from cell phone pings, right? These are anonymous pings that are lat-long locations from the cell phone. And in Armis's case, there are all sorts of devices, many of them like cameras and other security devices, but they're sending pings and data points on a continuous basis. And every event that's shared is timestamped. What's special about time series data and handling time series data? What do you need in these cases for IoT or real time with time series?
All right, with time series, sort of a special case, because what you're looking for is, tell me what's going on over some window of time. So a bunch of data comes in about, say, a given thing, and you want to say, over the last 5 minutes, what's the average, and how does that average compare to the previous 5-minute buckets? And doing that calculation is not easy to do. It's hard, it's hard to do if you try to write that code yourself. And so you really want a system that can make that bucketization of the time and the aggregations within the windows easy for you, so you can spend your time in the app focused on where you deliver the value. Now, this ANSI SQL language has these things called windowing functions built in that make it pretty easy to do that kind of capability. And then extensibility mechanisms that you can build on top to stitch things together and do more complicated things like interpolation, where you have to fill in values where you may not have complete values because data was lost. So having those capabilities built into the system just make it a lot easier to do things like time series.
Gotcha. Makes sense. Let's see how our poll shaped out. So how many database technologies are you using to support the application you're building? And the majority is more than 3. Really interesting result. Most definitely 2 of those are your OLTP and your analytics database, OLAP. Interested in knowing like what the third is, what the distribution of that third one is, if it's a cache or if it's an inverse index, etc.
We've typically seen people using more, not just 3, but 4, 5, 6, 7. We've seen some using upwards of 14 at the extreme cases. People use all sorts of stuff, trying to stitch it together, and it's just a function of them trying to solve this data intensity problem. I have all these different data coming in, and I have different dimensions of, I need to scale, I need to be able to do full text, I need to do geospatial, I need to be able to handle semi-structured. They keep bringing in more and more technologies to solve the problem, like creating complexity.
Yeah, and it becomes easier as well, right? It becomes easier to actually take care of that as well, right? I mean, like it's an assumption sometimes that, if at all we want to accelerate that use case, we might as well just use that specialized database to drive the results quicker. But sometimes when you do that, the application works fine, but then the data sharing, collaboration, consistency, and trustedness of data kind of goes away, because now you actually have these silos emerging in businesses as well, right? So
yeah, it's a challenge.
Right. So with that, I think that's a great segue, Noel, to your final topic of convergence and sort of the trend that you're seeing through Forrester research in the convergence of processing, data models, data types, etc.
Yeah, absolutely. It is another good topic of discussion, I guess, as well. Do we share?
Yep, Diogo, can you give sharing to Noel?
You guys can see my screen? Not yet.
Not yet.
Okay, here we go. Screens, technologies.
There we go.
All right. So, as Dominic and Rick were mentioning about the platforms, there is obviously, we see a lot of platforms out there, I guess, right? An operational platform is there, a transactional platform is there, analytical platform is there, a data warehouse, data lake. We got NoSQL, we got object stores, we got in-memory databases, we got graph platforms, you got relational databases still around as well, right? And now these are good actually, right? Sometimes when you are trying to build an application, you may pick one of them and start to work on it, right? And then someone else may pick another one because they're doing something like a data warehouse or maybe transactional system. And the bigger challenge with that approach is it's good because you can accelerate that use case you want to do, but in essence, sometimes they have to share data. Right? One system needs to share data from another system, or another application needs to share data with another application. How are you going to do that? Start replicating data. Replication works good enough for some degree. Sooner or later, it falls because or fails because performance issues, latency issues, security issues, right? And especially when it goes across multiple regions and zones, it can become a nightmare as well, right? So this is what we see happening. So what we are seeing is that these converged systems are emerging, right? So these extended data platforms, we call it, or the converged data platforms are critical for organizations to accelerate those use cases. So what we're seeing is a trend and a future direction of data management is that these convergence. So the multi-model data platform is an example here you see, which takes multiple of these things together in a single platform. Like, why do we have separate structured data separate, semi-structured data separate, unstructured data separate platforms? We don't need 3 different platforms, right? But also we don't need sometimes a different platform for different things, like maybe having document stores separated from graph. After all, this is all business data. Why, like, you don't have 3 phones, do you? Right? Structured data phone, unstructured data phone, or semi-structured data phone. That's one single phone. Why do you need 3 different things, right? So what we've seen as a trend is that some of these like document databases or graph databases and NoSQL or relational, some of these data is in silos. You need actually a converged platform that can drive a single platform for doing all these things together in a single platform. So this is an important direction we see. And the platform, what we see has been emerging over the last few years, is this multi-model data platform, which can do all these things together in a single platform. After all, this is all business data. Now, you have to make one single call to get to the data, whether it's document, graph, key value store, time series data in a single platform, right? And this is very important. As I mentioned, if you don't have that, then the developer writing the program would have to make 10 different calls. Time series call, I got NoSQL call, I got a relation database call, and that slows you down. And then consistency matters as well. So this is a big focus in the industry. Another area is translytical data platforms. And traditionally we've had in-memory databases and data platforms and operational databases separate as well. Now, translytical is this new emerging of these platforms which can converge transactional, operational, analytical workloads together in a single platform, so that you can do all these analytics things at a speed of transactions, right? Very fast involvement. So this is a big trend we start to see. And why is this happening now? Like the biggest question, right? Now, why is it now? And the big thing I would say is to do with memory processing, right? A large memory processing. We can do terabytes of tens of terabytes of data into memory, like DRAM and flash. But also we can do distributed memory as well now, right? So definitely we can do hundreds of terabytes into memory across a distributed architecture. So translytical is a composure of doing transactions, operations, and analytical workloads together in a single database. You don't need 3 different databases, one single platform. Otherwise, you have to move data from here to there and there. And biggest concern people have had with this is that performance issues, right? But there's also workload manager in the platform, but also there is memory processing through DRAM and flash, which really accelerates those use cases. And the third area we see is data management for analytical platforms, where some people call lakehouse, right? this converged platform between data warehouses and data lakes and big data. You don't need different platforms or different things. At the end of the day, what matters is more about my end results. I want to do customer 360, right? It sometimes doesn't matter whether you're putting it on a lake or a warehouse or a big data platform. You want to do customer 360 quicker and faster. So how do you do that, right? And that's why data management for analytics is a platform which composes all of these different data management attributes within a single platform. Whether you're doing streaming data, whether you're doing some legacy data, whether you're doing integration, or maybe you're building machine learning models in the platform as well. So this is something which we see emerging as well. We're going to see a lot more advancement in all these 3 different areas in the next coming years as well. Back to you guys.
Terrific. Thank you, Noel. I'd like to move on to our Q&A now. We've gotten a few questions, so thank you for that. And let's go into our Q&A. So let me find the first question here. So the comment or the question is, yes, the volumes of data are a major challenge, but how are we going to manage data that is complex, even more of a challenge than volume? So in other words, managing the complexity is even a greater challenge than the sheer volume. How will we manage the effects on workflow? Is government going to be a constraint? A global platform will make it even more complex in terms of language, business environment, culture, currency. Noel and Rick, what are your thoughts on that?
Well, I mean, there are certain regulations where data needs to be contained within a single zone. Like in Germany, you can't move data out of Germany, especially citizen data, right? So there is some obviously constraints around GDPR regulations and other regulations that need to contain data. And so we have seen these platforms becoming more data aware, which means that it knows it's got a built-in data intelligence, which knows that this data needs to be contained within this region, even though it could be accessed remotely if needed to be. So there's a lot of access controls and data protection regulations built into the platforms. Some of these are built into the platforms. Some of them, obviously, you may have to provide rules and policies to govern those things as well. So I would say it's a matter of balancing the act together. I wouldn't say that out of the box, it'll knows exactly your data and start to not move data out of that zone or country. But you may have to provide additional policies and governance and rules to really control that environment, right? But yeah, there is some of these things which are going to be there. But I think the real benefits is really being able to share this data across all these different applications and insights across the globe, which I think is it really has a lot of impact, especially as people start to leverage smart devices and smart applications globally, right? So yeah.
Anything to add? Yeah.
I think that's spot on. I think just to kind of recap that is that there's kind of 2 goals with data. One is you want to share it as broadly as possible with all the people who can benefit from it, and the other goal is to meet all your compliance and regulations and policies. And the problem is those goals are somewhat at odds with each other, right? Because either extreme is easy. If you want to share with everybody, dump it into an object store with a publicly open bucket, and everybody can just party on it. And so that meets the sharing goal, but violates the compliance goal. The other way is you lock the data down and don't let anybody access it, right? And that meets the compliance goal, and that's easy, but it means you're not achieving the sharing goal. And I think what we're going to see is this is going to be sort of the next wave of innovation and technology is how do we balance those 2 goals and provide a platform that allows you to meet both of them. And like Noel said, I think it's got to be down at the data layer. If you do it at the app layer, people can always bypass it. You got to teach the platforms to understand how to interpret it and express the policies in a declarative way and have the system guarantee it under the covers. It's the only way that the sharing and policy stuff is going to work.
I agree. Yeah. And I think the whole platform also could actually evolve through adaptability as well, right? Being adaptive towards the knowing of the business data and segregating and classifying it and then securing it as well and protecting it as well. And this is actually learning. So just like we have machine learning, we have data learning as well. The system needs to learn the data, which knows exactly what data we're trying to protect and govern. And today it may be manual as much, but then we do see the future of data management towards really making it more intelligent and automated. Like as you ingest the data, it automatically knows that this data, by the way, is customer data automatically, right? As opposed to telling that, hey, by the way, there's customer data coming in, right? So anyway.
So I think there's a quote in there, Rick. If your data strategy for data sharing relies on an S3 bucket and you're parting on that bucket, you might have a hangover. Next question here. Data is becoming more and more distributed. Is data consolidation dead, even for traditional analytics, for BI and statistics, for example?
Consolidation for what? Sorry, is that?
Consolidation for the purpose of traditional BI and analytics. If data is becoming more and more distributed, what's happening to data consolidation for the purpose of BI and analytics?
Yeah, I mean, basically, I mean, as I mentioned, there's like data fabric and data virtualization, which really brings together this data in a more logical sense. So physically, they may be distributed. You don't really have to move all the data in a lake and then do analytics. It's too late sometimes, right? By the time you move data into a lake and then do analytics, it's too late. We're talking about real-time analytics. We're talking about real-time APIs, right? And so we can't really move data so quickly sometimes, right? So the data, wherever the data is born, maybe it's created in an edge or a region, you may have to run analytics right there and move only the aggregated data into a maybe centralized location, right? So we do see BI taking a new form in a more distributed environment, not just that we have to traditionally move everything into a centralized zone and then run BI, but more distributed BI architectures will start to evolve as well. So.
Yeah, that's exactly right. It's not about consolidation. That wasn't the end goal. The end goal was, how do I join data sets? And if we can find a way to join the data sets without having to move the data, that achieves the end goal. And that's what we're seeing.
Join the data sets without having to move the data. So sort of to the trend that Noel spoke to earlier, the convergence. If you bring these different types of workloads together in fewer systems, there's less data movement, and you can join the data more easily. Yeah. I think this is a common question people have. What's the difference between data virtualization and data fabric?
Data virtualization and data fabric. Is that right?
That's the question. That's right.
Yeah. So data virtualization, we talked about it, is only about accessing. It's an abstraction layer which brings together this data silos together by a query language. So you query the data across these silos to get a data, right? So that's what data virtualization does. Now, when you go beyond the data virtualization, focus towards data fabric does broadly more data management capabilities. It does data ingestion, transformation, governance, security, preparation, quality. Those things are not there in data virtualization, right? FYI. So it's a broader data management. It focuses on the business use cases like Customer 360. Data virtualization does not do Customer 360. So you can evolve. Normally people will start with data virtualization as a phase one approach, and then go to phase two, being on data fabric as an easier route to doing that, because of the fact that you can actually understand your silos a lot better. So data virtualization is all about understanding your data and querying the data in a distributed environment. That's the basis. And then data fabric, as I mentioned, is more broad defined governance and controls of data management. It has data ingestion and transformation and governance and security and even metadata and catalog as well. So and the focus is more around those broader use cases like customer intelligence and IoT and fraud detection. What you're trying to do,
Right. Rick, what would you have to add to that?
Yeah, I think that's exactly right. That the data fabric is the broader sort of pattern, right? And federation is sort of a key part of it. And you're seeing data fabrics coming out from companies like IBM that are pulling all these technologies together and delivering them as a cohesive package, all fully integrated, making it easy for people to use.
Yeah, most definitely. And we have a partnership with IBM as part of their data fabric offering and SingleStore helps with that in simplifying into that convergence we spoke about earlier, to have fewer data stores to need to access within a data fabric that you're governing and maintaining. Terrific. Really appreciate everybody's questions today. That's about all the time we have in this session. I'd encourage you to go to singlestore.com/resources, where you can download a copy of Noel's research paper that we've been talking about in today's session, The Future of Data Management. A lot of great insight and market research there across the topics that we've discussed, a lot more detail than we had time to share here. Also, you can start, if you're not using SingleStore today, it's very easy to get started. You can start in the free tier or in our cloud with 500 free credits. Just go to singlestore.com and you can find that pretty easily. You also can run us in Docker and Kubernetes if you prefer to run it that way. And check out all the learning resources that we have online at docs.singlestore.com for the products docs, or in our YouTube channel, or right in the forum. So thank you for your time. Really appreciated your attention today. You'll receive a follow-up email from today's session, and this will be available on demand. So thanks everybody. Noel, thanks for joining us today. And Rick, thanks for joining us.
Great to be here. Thanks, Dominic.
Thanks.